Hello students, today we are starting the chapter Acids, Bases and Salts. In this acids, bases and salts, first we will discuss what is an acid. You all know, you have studied in lower classes about acid. Now acid is a compound which when dissolved in water furnishes hydronium ion. Now what is hydronium ion? This is hydronium ion, H3O+. Okay, so when an acid, let us suppose for example hydrochloric acid, HCl, dissolved in water, it will ionize and form hydronium ion H3O+ as the only positive ion and Cl- ion. Similarly, if you dissolve sulfuric acid, H2SO4 dissolved in water will form two hydronium ions because two H are here and SO4 2-. So you will see that an acid produces hydronium ion as the only positive ion. In actual practice, what happens? When an acid is dissolved in water, first it gives hydrogen ion and Cl- ion or whatever is the anion part. This H+ ion is very unstable. So it will combine with water molecule coordinately and then it will form hydronium ion. So this H+ will combine with water and form H3O+. That is how we write this. So an acid is a compound which when dissolved in water furnishes hydronium ion as the only positive ion. This is definition for acid. Now there are a number of acids which you all know. The examples of acids can be given like hydrochloric acid, sulfuric acid, nitric acid. Some other acids like acetic acid, formic acid. There are a number of acids. To understand them, we can classify them into different classes. So there are some criteria to classify them on the basis of. So the classification of acids. Now on the basis of first sources, on the basis of source from where they are obtained. So on basis of sources, acids are divided into two classes: inorganic acids and organic acids. Now inorganic acids are derived from minerals. So they are also called as mineral acids. Examples: hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, sulfurous acid and so on. Organic acids derived from plants and animals. Okay. Like citric acid, you find this in citrus fruits, oranges and all. Acetic acid, which is used as vinegar in food. Formic acid, when any ant bites, you get some burning sensation, that is because of this formic acid. So they are basically formed from plants and animals. There are a number of organic acids: tartaric acid, malic acid, oleic acid, lactic acid and so on. So basically mineral acids or inorganic acids are strong acid, although there are some weak acids also like carbonic acid, but they are very strong acids also. Organic acids are generally weak acids. Okay, so this is first classification. Now second one, on the basis of basicity. Now acids have basicity. Now why is it called basicity? It shows that one molecule of acid combines with how many molecules of base to form salt and water. Okay, so basicity of acid can be defined as the number of hydronium ion furnished by one molecule of acid when dissolved in water, it will be its basicity. Okay, so if one hydronium ion is furnished, basicity will be 1, 2 then 2, 3 then 3 and so on. So on the basis of this, so for example if I am writing HCl plus H2O, we know it furnishes H3O plus Cl-. So how many hydronium ions are there? Only one hydronium ion is there. Here is only one hydrogen ion is also there. So there is no more hydrogen with this anion. So one hydrogen has come out in the form of hydronium ion. So it will be, its basicity will be 1. So it is called monobasic. So we can classify acids on the basis of this basicity. Now here one thing you all have to remember, that some acids like organic acids mostly will have a number of hydrogen atoms. So it doesn't mean that all are replaceable hydrogen ions. The hydrogen ion which can be replaced will only determine the basicity. Okay. So for example, if you write acetic acid CH3COOH, here 3 plus 1, altogether 4 hydrogen are there. It doesn't mean its basicity is 4. Its basicity is 1 because only this H can be given like this in water. If it is dissolved in water, it gives CH3COO minus plus H3O plus as the positive ion. Now these H will not come out in the form of ions. So you can understand that hydrogen ion which is attached to oxygen can only be given out, not the others. So it is very important to see whether the hydrogen is attached to oxygen or not, if there is oxygen in molecular formula of acid. Okay. So now we will see how many classes are there on the basis of basicity. So the first class is monobasic acids. Now as the name says, mono means basicity will be 1. So monobasic acids, if one molecule of an acid furnishes one hydronium ion in its aqueous solution, then it is known as monobasic acid. So again HCl, already I gave you example. Now another we can see HNO3 plus H2O, it will give H3O plus plus NO3 minus. One hydrogen, it has come out in the form of H3O plus. Now look at the anion, it is NO3 1 minus. There is no hydrogen, that means all the replaceable hydrogen ions are replaced, nothing is. So it is complete replacement. Okay. So from this we can come to the characteristic of monobasic acid, that it ionizes in one step. Ionizes in one step. Monobasic acid ionizes in one step. There is one hydrogen removed in the form of hydronium in one step. There is no more hydrogen left. Second one, it forms one type of salt, that is normal salt. Okay, only one type of salt will be formed, that is normal salt. Now what is normal salt? If in the formula of all the hydrogen of acid are replaced, that means complete replacement of replaceable hydrogen ion takes place, then the salt is formed and it is called as normal salt. If partial replacement is done and there is hydrogen ion, replaceable hydrogen ion is left behind in the formula of salt, then it will be called as acid salt. Same thing will happen with bases, then it will be called basic salt, that will be taught later. So this is one example I will give you here. We have taken HNO3. So now let us suppose this HNO3 reacts with a base. Neutralization reaction will take place and salt and water will be formed. So this HNO3, if combines with NaOH, aqueous solution, okay, so it will give NaNO3 plus H2O. So this NO3 anion is going with this metal and this part is going in the form of H2O. So this is the salt form and there is no more replaceable hydrogen ion present in this. So this is a normal salt, sodium nitrate, a normal salt. Okay. Now second kind of class of basicity is dibasic acid. Now what is dibasic acid? Dibasic acids, by this time you all might have understood that if one molecule of an acid on dissolution in water furnishes two hydronium ions, then it will be called as dibasic acid. And the examples are H2SO4, so 2H3O plus will be given. Okay. So H2SO4, sulfuric acid, When sulfuric acid dissolved in water, it gives H3O plus hydronium ion plus HSO4 minus. So at a time only one replaceable hydrogen ion is replaced. So in the first step, one hydrogen from here has come out and made H3O plus. One hydrogen is left behind. It has come out in the form of HSO4 ion, which you know as hydrogen sulfate ion or bisulfate ion. Second step, again this bisulfate or hydrogen sulfate ion will undergo ionization, and this hydrogen ion will come out in the form of H3O plus plus SO4 2 minus. So together, how many hydronium ions have come? 2 hydronium ions are furnished by this one molecule of H2SO4. So what is the basicity of H2SO4? 2. Now, so looking at this, you can say that dibasic acid ionizes in 2 steps. In 2 steps. Second, what will happen when salt formation take place? There will be 2 types of salt. Okay, one salt with this anion, another salt with this anion. So 2 types of salts. 2 types of salts will be formed. Okay, so first one will be acid salt, because first salt will be formed with this anion where one more replaceable hydrogen ion is there, and with this normal salt will be formed. Okay, so we will write equation for that. Let us suppose sodium hydroxide is reacting with H2SO4. Now it will give first NaHSO4 plus H2O, sodium hydrogen sulfate. Okay, this is acid salt. If more amount of sodium hydroxide, so another step you can write as H2SO4, then it will form Na2SO4 plus H2O. So this is normal salt, sodium sulfate. You can also write this equation like this. You can continue with this, like this NaHSO4 in the second step will react with some more sodium hydroxide and give Na2SO4 plus H2O, one and the same, like this or like this. So in this way you will find 2 types of salts are formed, acid salt and normal salt. This is all about dibasic acid. What are the other examples of dibasic acids? Sulfuric acid, sulfurous acid, hydrogen sulfide, carbonic acid. So H2CO3 carbonic acid, H2S, H2SO3. These are some more examples of dibasic acids. Now third class is tribasic acid. The tribasic acid, as the name suggests, 3 hydronium ions per molecule of acid will be furnished in its aqueous solution. Okay, so you can, by this time you also can understand that 3-step ionization will be there, so 3 different types of salts will be formed. Any number of salt, but normal salt will be only 1. So out of all the 3, 1 will be normal salt which will be produced in the end, and first 2 will be acid salt, which because this is an acid. So tribasic acid example, phosphoric acid, H3PO4. Now here you see there are 3 replaceable hydrogen ions are there. These ions will be given one by one in each step. So first, when it will combine with water, it will give H3O plus hydronium ion, obviously because it is an acid, and the anion H2PO4 minus. That is called as one anion, dihydrogen phosphate anion. Then this dihydrogen phosphate will combine with one more water molecule and give H3O plus and HPO4 2 minus, hydrogen phosphate ion. Now this hydrogen phosphate ion will combine with water and form one more H3O plus and PO4 3 minus phosphate ion. So this is dihydrogen phosphate and phosphate ion 3. Here you can see that two replaceable hydrogen ions are still there. Here one is there, here no hydrogen. So obviously the salt formed with this anion and this anion will be acid salts, and the last one will be normal salt. So 3-step ionization. So it will undergo 3-step ionization or ionizes in 3 steps. Anyhow you can say. Now we will see how many types of salts are formed. 3 types of salts are formed. So I will write the equations once again. I will rub this off. You remember this. So again we will take NaOH plus H3PO4. Okay. So this NaOH and H3PO4 will give you NaH2PO4 plus H2O. This is neutralization. So salt and water will be formed. The hydronium ion will be water. So this salt is called sodium dihydrogen phosphate. This is first one. The second one, if 2NaOH plus H3PO4, then it will give Na2HPO4 plus H2O. See here, one sodium was there. Now 2 sodium, so 1 hydrogen is replaced by 1 sodium. So this is known as sodium hydrogen phosphate. Acid salt, acid salt. And the third one is NaOH plus H3PO4 will give you Na3PO4 plus H2O. Sodium phosphate. So out of these 3, 1 was replaced, 2 were there, 1 replaced by sodium. Out of this, again here 2 replaced and all the 3 are replaced. So these 2 are acid salt and this is normal salt. So this is classification on the basis of basicity. Now third criteria for classification is the third criteria for sources and second basicity. Now third is concentration on the basis of concentration. Now what is concentration? Concentration means if you look at an acid and measure the amount of water present in this. So how much acid is there and how much water is there. So the acid and water proportion tells us concentration of acid. Now on the basis of this, acids can be divided into 2 classes, concentrated acid and dilute acids. Now you all know concentrated acid. Now concentrated acid means in the mixture of acid, water will be very less or no water will be there, lots of acid, high amount of acid. And dilute acid, when compared to amount of or volume of acid, water is very large volume is present. So if water is more, then it will be called as dilute acid. Now fourth one is on the basis of strength of an acid. Now you heard about strong acids and weak acid in sources while teaching. I said inorganic acids usually strong and organic acids are weak acids. So what is strength? How is it measured? Strength is measured with respect to degree of ionization. Now what is degree of ionization? We can calculate, there is a formula to calculate degree of ionization. Okay. So degree of ionization is calculated when we dissolve acid in water, the molecules will undergo ionization. If all the molecule or almost all the molecules are undergoing ionization, then the ions will be too large, high concentration of ions will be there. Okay, so strong acid. If very less molecules are undergoing ionization, then less number of ions will be there, and this will be known as weak acid. Okay, so now let us suppose, so first I will write degree of ionization, which is represented by symbol alpha. So alpha, or degree of ionization, how to calculate? Number of ionized molecules of acid upon total number of molecules of acid multiplied by 100. This is the formula to calculate degree of ionization. Let us suppose we dissolve 100 molecules of acid in given volume of water. If all the 100 are ionized, then 100 upon 100 multiplied by 100. So degree of ionization will be 100%. If 60%, 65 molecules, then 60%, 65%, 25%, if 25 molecules, so that we can calculate like this. It is found that if the degree of ionization is 30% or more, then the acid is considered as strong acid. Okay, so now on the basis of this, already I told you there are two classes on the basis of strength: strong acids and weak acids. Now, strong acids, when the acid ionizes completely, almost completely in its aqueous solution and furnishes high concentration of H plus ions. Strong acid examples are H2SO4, sulfuric acid, hydrochloric acid, nitric acid. Weak acids, when the acid ionizes partially and gives very low concentration of H plus ion, so that the degree of ionization does not reach to 30%. Now weak acids are all organic acids: H2SO3, H2CO3, these all are weak acids. So this is the fourth type of classification. Now the last one, fifth one, is on the basis of molecular composition. What is molecular composition? If you look at the molecule of an acid, you will see what all the elements and atoms of elements are there. Okay, so on the basis of this, we can classify them into two classes: hydra acids and oxy acids. Now, any acid, that means hydrogen atom has to be there, hydrogen ion will be there, otherwise it won't be acid. Okay, along with hydrogen, if there is no oxygen, only hydrogen and any other ion, anion will be there, then it is known as hydra acid. For example, HCl. There is H because it is an acid, and Cl, there is no oxygen, so this is hydra acid. Okay, now there are some acids which have oxygen along with hydrogen. They are called as oxy acid. For example, here some more you can give, like HBr, HF, hydrobromic acid, hydrofluoric acid, H2SO4, H2SO3, HNO3, number of acids. Here along with this hydrogen there is also oxygen, so these are called as oxy acids. So oxy acids and hydra acids. This is all about classification of acids with respect to 5 points: sources, basicity, concentration, strength and molecular composition. Now we will see action of dilute acid on certain substances and find out which gas is given out. So action of dilute mineral acids, or dilute acids rather, acids on first carbonates, metal carbonates, let us suppose we are taking a metal carbonate, sodium carbonate or potassium carbonate plus acid. if it is treated upon with acid dilute. It's very important to write dilute over here because dilute has its properties are different and concentrated are different. So potassium carbonate when reacts with HCl, so it will form KCl, okay, and what will be given out here? This K has come out H2O plus CO2. So the gas which is coming out is carbon dioxide gas. Second one, with metal hydrogen carbonate. With reaction with hydrogen carbonates, we can take the same one, potassium bicarbonate or hydrogen carbonate. Let us suppose it reacts with sulfuric acid, which is dilute. What will it give? It will give K2SO4 plus H2O plus CO2. Okay, so here you will find this will be carbon dioxide gas coming out. Now the third one is action of dilute acids on metal sulfides. Third, metal sulfide. Sulfide means SO3. Metal sulfide, you can take K2SO3 plus HCl. It will give KCl plus H2O plus SO2. So what is the gas coming out here? Sulfur dioxide gas. The action of dilute acid on metal carbonate and sulfide, if you compare, you will find that their carbon dioxide gas was coming out and here sulfur dioxide gas. That's it, remaining all are same. Fourth one, on metal sulfide. Sulfide S2 minus. Okay, so metal sulfide from potassium to copper and all these, any metal carbonate sulfide you can take of your choice. Let us suppose we are taking iron 2 sulfide plus make it react with dilute H2SO4. It will give FeSO4 ferrous sulfate plus H2S. What is this H2S? Which is hydrogen sulfide gas, rotten egg smell gas. You all know this. So this is how. So you will find that there are the gases which are coming out by the action of dilute acid on all these different compounds are different. And like this you can do this in your lab while doing your practicals. Okay. This is all about acids.